An interesting issue is p-hacking and publication bias in causal analysis in economics. This is a paper by Brodeur and others, published in the American Economic Review 2020. Why is that interesting? Well, we know that P smaller than 5% is a kind of magical threshold for some, and if the p-value is below 5%, then, at least in social sciences, the 5% thresholds divides results to significant ones and to insignificant ones if p-value is above the 5% threshold. So if you just look at the p-value, that might be misleading, and p-hacking is the issue that you want to get significant results, right? So you want to get significant results, and that means that you want to get as many stars as possible in our terminology. And if you have a lot of stars with respect to your estimated regression coefficient, then this is good news, and that might lead to publications in refereed journals. To be a little bit more formal, so if your estimated regression coefficient is, let's say, 0.1, then you typically report the estimated standard error in parentheses below the estimated regression coefficient. Let's say this is here now 0.05. So we see here the regression coefficient beta 1 hat is 2 times the estimated standard error, and that's our rule of thumb. So if the standard error is that small, then your regression coefficient turns out to be significant. So that's the rule of thumb. You also could translate that in a t value, right? So the t value is, or the rule of thumb with respect to the t value is also that the t value in absolute terms, if it's above 2, then you reject the null hypothesis. And as you know, the t value is nothing else than the beta 1 hat divided by the standard error, the estimated standard error of beta 1. So that's what you know from your basic econometrics course. So this is just another way to put that. Right, having said that, we should have a closer look then to the estimated standard error to get a feeling for the p-hacking issue. Assume now you got, as a result of your estimation, a beta 1 hat of 0.1. Okay, so the beta 1 hat is covariance xy over variance x, and that's your regression coefficient, and the sign of the regression coefficient depends on the covariance. So if the covariance is larger than 0, then the regression coefficient will be larger than 0, and if the covariance is smaller than 0, then your regression coefficient will be negative. Okay, that's what we are familiar with. Okay, now the second question is this regression coefficient positive or negative? Is it significantly different from 0? And that depends on the estimated standard error. Assume now your estimated standard error would be 0.1. So in this case, the regression coefficient wouldn't be different from 0, so it wouldn't be statistically significantly different from 0. Wouldn't be significant, to be short. Now you know that the standard error, the estimated standard error, is the ratio standard deviation over root n. And what you could do, and that's the p-hacking issue, what you can do, you can increase the number of observations. If you increase the number of observations, then the denominator gets larger, then the ratio gets smaller, and then the estimated standard error gets smaller. So the estimation gets more precise. So what happens then? You increase the number of observations, and then your standard error, which was 0.1, goes down to 0.08. It's still not significant, right? Then you increase the numbers of observations even more, and then your estimated standard error might go down, let's say, to 0.04, and now it's getting significant. And then you increase the number of observations again, and that leads to a more precision, and then you might end up with a very small standard error, and your regression coefficient is highly significant. And that's what is behind the p-hacking issue. And this article here is about the incentives or the hazards that are associated with that. Publication bias, you want to get your papers published, and the probability to get it published is if your results are significant. If your results are not significant, you are always in the defense, and you should come up and, well, the sign is correct, however it's not significant due to some other reasons. You're already in the defense. And if your results are significant, you're not in the defense as an author. And it's easier, on average, of course, it's easier to publish your stuff. So there's a high incentive for researchers to come up with significant results. And that's what is discussed here in this article. So why did I pick this article? Well, it's good news to know that p-hacking and publication bias is an issue, but varies greatly by method, and especially RCT are not that much hit by the issue. That's the good news. On the other hand, it's of course bad news that some methods like IV and to a lesser extent DID are, with respect to that issue, particularly problematic. That's what I find here after having done a lot of research here and checking a lot of articles in leading journals. So this is the overall result. So let's be cautious with respect to that, and I will also have a critical look on that issue with respect to RCTs. Because even if you look at RCTs, you will observe, so over time, that the number of observations have gone down in practice if you come up with a randomized controlled trial. Just as an aside, here they talk about randomized control trials. Others talk about randomized trials, and mostly you see randomized controlled trials. Everything's correct, but just to make that clear, it's not standardized how you talk about these issues. But RCT, that's an acronym we can use here as a translation of a trial with a program and a control group that are comparable. Now I want to highlight a couple of notions. So first, the credibility revolution in empirical economics has been marked by a shift towards methods explicitly focused on causal inference. So credibility revolution means that our field mainly referred to theoretical analysis for quite a lot of decades, and the same is true for labor economics. By the way, had you participated in a conference I participated in 1998 in Belgium, somewhere in Belgium, 95% of the papers were theoretical papers in that conference, which was the European Association of Labor Economists conference. Then 20 years later, just take that in Lyon, 2018 in Lyon, 95% of the papers used methods like that. Just to make that clear, our field has dramatically changed, and labor economics is one of the core fields in economics. And with respect to these methods, labor economics is pretty much progressive, and other subfields are joining that. And if you look at the JEL code, right, and the JEL code has a C93 code, which stands for field experiments, which is not pretty new, but meanwhile, maybe 15 years ago, they inserted a code especially for field experiments. So this is some indicators that things are changing. So if you want to become a successful economist in practice or in academia, then it makes absolutely sense to do causal inference. Causal inference, so this is also something that is now pretty often used. So typically we talk about statistical inference, right? And the idea is you have a sample, and based on the sample you want to know something about the true values, and the true values are the population values. And causal inference now says, well, we want to learn from a sample something about a causal effect that is true for a population. Just to clarify these notions, maybe that helps. And also what we are doing here is applied microeconomics, right? And 20 years ago, we talked about microeconometrics. Meanwhile, it's more that we say it's of course still microeconometrics, but it's applied micro. And applied micro always means you want to get some insights based on data. And inference and statistical significance, the relationship between these two guys is highlighted here. And I already explained the notion of publication bias in detail, and also the notion of p-hacking. I don't repeat it now. So without going into the details of the paper, we should be aware that as Imbens stated in his 2010 paper, that randomized controlled trials occupy a special place in the hierarchy of evidence, namely at the very top. So the gold standard RCT is not challenged by this paper. So the authors are fully aware of the critique that has been pronounced by Deaton Cartwright. They refer to the Deaton Cartwright paper I discussed in our last session. So RCT as the gold standard, and they are fully aware of that critique. But here, as far as the propensity for the published literature using a particular method to exhibit p-hacking and publication bias, our results indicate that RCT outperforms the other methods. So that's what we should keep in mind. It's relatively the best. On the other hand, what we should also mention is that economic literature is not that prone to that issue. It's more sociology or psychology. So it does play a role in economics, but it's not that prominent as you might think. And it has also something to do with experience. So Brodeur, in their previous article, suggests that less experienced researchers are more prone to p-hack on average. Well, because that's pretty easy, right? You just look at the p-value and then you say significant or not. But that's of course something that is superficial, and if you have a closer look, you do not only look at the p-value, look first on the sign of the regression coefficient. Is the sign in line with your theory? And second, you look at the standard error. And then a third look is also on the R-squared. And then you should be also aware how many observations you have. And putting all together, and if it's a multiple regression analysis, the F-test gives you also a hint what's going on, right? So it's not only the p-value, right? It's not only the p-value, it's a whole set of different indicators that makes your assessment of an estimation. So this was enormous work, probably with lots of student helpers, research assistants. So they checked a lot of refereed journals, they checked the different methods and the different tests and hypotheses, and overall more than 20,000 were analyzed. It's interesting to see that the top 5 journals, RCTs, that's the highest share here in comparison to diff and diff, IV, RDD. The overall lesson, the take-home message from this article might be that we are just aware of the issue of p-hacking, and we are aware of publication bias. We cannot change the rules from one day to the other, but there is progress in research transparency in the forms of data availability. You can get the data. Typically, authors have to provide the data, and then you can check the results on your own using this data code or the R code, and other things like pre-registrations, pre-analysis plans, and declared openness to publish null results, so that you can check more as a referee, but also as a reader, what's going on. And that's the progress we can see in reality. Okay, so we are getting more critical with respect to the empirical methods we use, and that's then scientific progress, and let's see how things will be in 20 years. So I have an overview of more than 20 years, but it will be interesting to see what's going on in the next 20 years, and that's what you will see in your future career.